And here we are. Welcome. I'm excited to see some people here. What we're doing today is sort of a replay of the Shotgun Developer Day courses that we did at SIGGRAPH just a couple weeks ago. We had a full day of courses on all the different ways that you can develop, write code, build out, customize, extend your Shotgun experience. And so what we're doing now is we're redoing all of those courses as webinars and recording those so that we'll have them on hand so that people who couldn't be there in Vancouver can have access to all that great information as well. I am going to share my screen and get started. We have two today. Actually, I'll say that before I do get started. I'm going to start with basically an intro to all of our platforms, all the kinds of development that you can do and the real world ways that you can use them. And then after that, we have Boucher here, who is my street team, sort of street engineer colleague on the Shotgun web app side. And he's going to dive specifically into some of our platform API development. All right, let me share my screen. I'm doing like a keynote remote from my iPhone thing, so this will be fun. Okay, let's get started here. Okay, I think you guys can all see my deck. So let's begin. Like I said, intro to Shotgun development. I think that in this arena, you guys probably already know me, but just in the order of a quick intro, my name is Tannaz Sassooni. I am on the street team, sort of street engineer group as a toolkit specialist. I've been at Shotgun for about 2.5 years. Before that, I was at Rhythm & Hughes for 3 years early on as a pipeline TD, and then at DreamWorks Animation for almost 9 years as a pipeline TD in a variety of departments. Here we are. Before we get started, I just wanted to let you guys know we have a GitHub repo with all the resources from the day, PDFs of the slides, as well as like the code examples and some links to documentation and other useful stuff. This QR code will get you there, and you can also see the URL down below. In addition, I'll point out quickly, we have this awesome graphic from Mason Jarrett, who's one of our very talented street team members. He drew this up just of his own volition, and it's so awesome. And I've been told that if anyone wants to get this design as a tattoo, Don Parker will pay for it. So, okay, let's begin. As we go through the courses, like I mentioned, we're going to take detailed looks at all the different ways that you can write code for Shotgun. But to start, I wanted to introduce you to a few real-world scenarios from production. They're made-up real-world scenarios to show you how useful this kind of development can be. Over the course of this talk, we'll learn about action menu items, event-driven triggers, toolkit hooks, and our APIs. But to begin, let's do a little bit of history. As you already know, Shotgun's web app gives you a powerful cloud-based sort of source of truth for all the minute details of tracking a CG project. From casting to tracking progress to managing assets, you can find everything in the web app. So we started with the web app, but quickly studios wanted even more from their Shotgun data. Now that we have all this data, why not use it to drive your file naming structure and directory structure for artists' files? Why not track publishes back in Shotgun? So out of those desires came the pipeline toolkit. Plug-in integrations into widely used DCCs, and of course by DCCs I'm referring to digital content creation software, your Maya, Nuke, Houdini, Photoshop, Motion Builder, so on and so forth. Anyhow, plug-in integrations into widely used DCCs that extend the Shotgun experience into the artist workflow and also give you the foundation for a basic publish pipeline. The toolkit, an animator can automatically save their Maya file to the right place with the Work Files app, or when a character rigger is ready to share their latest version of their rig, they can publish it with the Publish app. It will be tracked in Shotgun, and then other artists can pick it up with within their own DCCs with the Loader app. I can show you some examples of that in action. Here's our apps inside of Maya, and again, advance inside of Nuke. So we know that this gives us a lot of power right off the bat, but we also know that studio workflows are not one size fits all. Far from it. Like, every studio has their own special quirks and ways that they want to work, and they have their own workflows. And so while the customizations that are offered through Shotgun Web App and the toolkit configuration get you very far, sometimes you want to take it even further, customize and extend your pipeline even further. And so that's where APIs come in. The various Shotgun APIs give you the power to use those out-of-the-box products as a starting point. And from there, customize as far as you can go. You can automate repeatable tasks. You can build triggers, integrate Shotgun into your existing tools in your studio, and more. So like I said, through these courses, we're going to dive deeper into each of these facets of Shotgun development. But right now, I want to go through with you guys some scenarios in order to touch quickly on the different ways that you can interface with Shotgun in your development to build better pipelines. So the first scenario is Nadia. Nadia is a production manager at a VFX vendor studio. And in case that terminology isn't clear, when we talk about VFX vendor studios, the idea is that the client in this scenario is a film production, for example, studio that's producing a film needs to do some VFX, and they hire out a vendor studio to do that work and deliver it back to them. So Nadia is a production manager at the vendor studio doing VFX for a client production. Her show has some shots already in production, and they're beginning to start delivering things to the client. The client has asked to see the renders that they're getting from them in QuickTime format, in addition to the EXR sequences that her artists are rendering. The client has very specific naming conventions, and Nadia wants to keep all of the media that they're delivering organized on disk in per shot folders. She's noticed that this manual process is tedious and time-consuming for her production coordinators, so she wants to provide them with an automated way to do it right from within Shotgun, which is where they're already working anyway. So that's where action menu items come in. With action menu items, or AMIs, as we call them, you can add custom scripts to the right-click menus on any entity in Shotgun, any project entity in Shotgun, and those can run arbitrary Python code. Nadia has her pipeline TD set up an AMI so that when you right-click on a shot entity in Shotgun, you have a prep for client menu item. When you choose it, the EXR file sequence will be converted to QuickTime. It will copy and rename both the EXRs and the QuickTime to match the client's naming convention, and it'll place all of it into per shot folders within a designated client outbox on disk. So AMIs are super useful. You can use them for things like creating an upvote or like system in your studio, say for tickets perhaps, or if you want to be really weird and diabolical perhaps for versions, for renders. You can use it to generate thumbnail PDFs from a selection of entities. You can use it for archiving old assets. There's a ton of things that you can do there. So that's it. Now that Nadia is all set with her AMI solution, let's continue. Next scenario is Violet. Violet is a layout supervisor on an animated feature. Her artists are rapidly going through shots, and currently she is a PA spending time going through and switching the anim task on each shot to ready to start every time the layout task is set to final. She wants this process to be automated, but in this case it would defeat the purpose to have an AMI, because then her PA would just be running this AMI instead of setting statuses. It should just happen automatically, is what she thinks to herself, anytime that a layout task is finalized. So for Violet, we have event-driven triggers. Shotgun logs every event that takes place on your site. Logins, values being set on fields, entities created and deleted, etc. We offer a framework with which you can spin up a daemon locally that monitors that stream of events and runs plugins when it sees events that fit filters that you can specify. So in Violet's case, her TD can spin up an event daemon and write a plugin whereby anytime the layout task on the shot has its status set to final, the animation task that corresponds on that same shot will automatically have its status set to ready to start. So you can see how this can really quickly get rid of a lot of tedious tasks. There's a lot that you can do with event triggers. You can notify your artists if a shot goes on hold or is out of picture. You can add versions to smart playlists when they're created. You can create a daily playlist so that your team can see their colleagues' latest work. Or you can assign artists to a project when they're assigned to a task on that project. And these are all, just a few examples. So Violet's all set with her event-driven trigger. So let's talk about Jed. Jed is a crowds lead. The animation team on his show is using the Toolkit publisher to publish animation as Limbic caches. But he wants his crowds artists to be able to pull animation into their massive sessions, which requires the geometry to be in the FBX file format. He wants these FBX files to be readily available without artists having to take time to generate them sort of on demand. So here we enter our toolkit hooks. Our toolkit apps have been designed with hooks, bits of logic that's separated from the main code so that they can be easily overridden and extended. These are used in commonly customized steps. They're small scripts that are easy to modify without forking. And we have app, engine, and even core hooks so that you can modify the functionality of the toolkit core itself without having to fork core. So for Jed, he can use that file format conversion. At publish time, he can write a hook that, or he can have his TD write a hook rather, that when animation publishes, it will generate those FBXs for his crowds team, and they'll be readily there for them. Some other examples of hooks are, like we said, file conversion to or from in-house formats. You can add needed command line arguments when you launch software. Sorry, there's our command line argument when you launch software. Something cool you could do is add an action to the shotgun panel to generate a reference image plane inside of Maya, say for your animators. And once again, sky's the limit. So Jed's all set, finally. Let's talk about Lily. Lily is a pipeline TD. She works at a large studio with a lot of custom code and established user experiences for their artists. For her, the challenge is getting her studio's in-house tools to access and modify her shotgun data and writing apps that fit into her studio's existing pipeline. For Lily, we have a small handful of APIs as well as tools to get her started on custom app development. The best graphic here again is our awesome design because it covers all of these things. Up at the top, we have our simple Python-based API for accessing Shotgun and integrating with other tools. It's got CRUD methods that give you raw access to data going in and out of Shotgun. On top of that, the Toolkit platform and its API allow pipeline TDs to quickly build configurable tools that can run across applications. And then just in the past few months, we've released a REST API. It has functional parity with the Python API, but it gives you all that full data access for cases where Python isn't the right choice. For example, if you want to write something in JavaScript, Go, C++, whatever. Since Lily needs to write some custom apps, we offer a couple other helpful starting points. We have a starter app, which will give you a framework to build your app upon. And then what we're seeing here is the demo app. It includes examples of common UI elements as well as their underlying code. So it's really useful for seeing examples of the things that you want to be building into your apps. So with all of these scenarios that we talked about, the big takeaway should be that with all these touch points, Shotgun can make it feel like your one TD is doing the work of 10 TDs. With AMIs, event-driven triggers, and toolkit hooks, we've laid the groundwork so that very quickly you can extend and integrate your Shotgun workflows both for production management and for your artists without having to start from scratch. And even when you are starting from scratch, you have rich, intuitive APIs and tools to get you going, so you're not really starting from scratch. So in the next half hour, Patrick's going to walk you through some examples of using our APIs, but before I hand it over to Patrick, does anyone have any questions? I'm going to close my deck so that I can see what's going on. No questions? Okay. All right then, I think that I will stop sharing my screen and hand it over to Patrick.
All right. Thank you so much, Tannaz. Let me share my screen and let me know when you see this. All right, you should be seeing the intro slide, is that right?
Yep, all good.
Perfect, thank you. Thanks for the awesome setup, Tannaz. So now I'm going to take over, and for the next 30 minutes or so, we're going to be talking about data management in Shotgun using, obviously, Shotgun's APIs. A little bit about me, for those that don't know me. My name's Patrick. I've been with Shotgun for 6 years, and most recently as a technical support engineer on the web app side. Prior to that, I was a pipeline engineer for various facilities for give or take 13 years or so. This is an intro course. This is a 101, if you will. And when people are new to programming with Shotgun, they often wonder how and where to get started. Well, you're here, so one could say you've already started. Actually, where I like to suggest people start is generally with a Python API, which was at the top of the awesome graphic that Mason drew out for us. As Tannaz mentioned earlier, we do have a REST API, but in the interest of time, I'm going to be referring you to a great webinar one of our engineers, Brandon Ashworth, recently did about REST, and instead I'll cover the Python API. If you're a beginner, a lot of concepts of the Python API are easily transferable to REST. We're also going to be skipping over Shotgun Event Daemon due to time constraints because it's a pretty large and loaded subject. But you can always reach out to the support team or myself if you have any questions about the Shotgun Event Daemon. So if we're skipping over all that, well, what's left? Well, here's what we're going to be looking at more specifically and what I hope your main takeaways from this talk are going to be. We're going to look at how to set up a script entity in Shotgun and connect via the Shotgun Python API. We're going to look at querying, creating, and updating data. We're going to look at what entity dictionaries are and the special name key that exists in linked dictionaries. We'll also take a look at linked field syntax, or what you'll sometimes hear us referring to as being the bubble field syntax. We're going to take a look at uploading files via the Python API. And we're going to look at how AMIs work, how to set them up, and how to use Flask to write a simple AMI. Concerning the last icon there, AMI is also the acronym for the American Motorcycle Institute, so you get a puppy on a motorbike. If at any point you feel like this picture of Beaker is you, and you're freaking out a little bit, because you're a beginner, that things are going too quickly and are getting out of hand, remember that all the friendly Shotgun staff is here to help you. You can reach them at support@shotgunsoftware.com. And also, don't forget, all this content will be is available in a GitHub repo. There's going to be a QR code at the end of my slides, which is the same that was at the beginning of Tannaz's slide. So you can just grab a picture of that and get to our GitHub repo lickety-split. All right, for the sake of argument, let's imagine a scenario where you're using Shotgun for your review process. Usually, version submission starts out with users uploading content manually via drag and drop in the web app. This can be pretty time consuming, especially if you have 100 versions to submit. This is where the API can come in handy, as tools can be written to automate the review submission process. Our tool isn't going to be a complex one. We're going to keep it to its simplest form possible. Once the tool runs, here's what we'll be left with: a version with a clip uploaded to it. For this to work, we're going to need to connect to Shotgun, fetch the project and shot the version is going to be linked to, create the version, and finally upload the movie to the version. Let's talk about what you'll need to make this work. Well, obviously, a key requirement for the Python API will be Python itself. If you're on Windows, you can opt for Active Python, which will come with PyWin32 and a bunch of other goodies. If you're using REST, or REST API, any language with an HTTP or REST library will do. For Python users, I like to recommend the requests library if you're going to be going down that route. You'll also obviously need the Python API itself. You can get it via a link at developer.shotgunsoftware.com. Or alternatively, developer.shotgunsoftware.com/python-API. It'll take you directly to the Python API docs. You can also go directly to GitHub if you want and grab the latest tag out of the public repository for the Python API that we've got. It's really easy to download and install with all the docs present there. Finally, you're going to need a script name and a script key. There are many ways to authenticate using the Python API, but this is the simplest one and the one that you're going to see in this example. To create your script key, you'll press the user menu icon in the top right of the Shotgun web interface, and you'll select scripts. You need to be an administrator to do this. In the scripts page, you can create a new script. You give it a name, and you jot down in a secure location the application key that is going to be generated. You probably noticed that there are multiple script keys in the screenshot. Why do we have multiple script keys? Well, having more than one key, and preferably one key per tool or script that you're writing, will allow for better control over your tools and better auditing of which tool performed which change in Shotgun. As your pipeline grows, troubleshooting it is going to be much easier if you have multiple keys instead of a single one. Okay, sorry, let's start our tool and go fetch some data with the API. This is the first part of our tool where we connect to Shotgun and go retrieve the data. First, we import the Shotgun API so that we can create a connection. And then the second block of our code just stores into variables our script name and script key information that we created in Shotgun along with our site's URL. You shouldn't store this information directly in your script. This really isn't secure. Preferably use something like environment variables or other more secure techniques. This is really just example shorthand. Also, yeah, the script key is bogus. Don't worry, don't need to copy it. It's not gonna work. All right, next we're gonna create a connection to our Shotgun site's URL and authenticate using the stored script key, script name and script key. You can also authenticate with a normal username's with a normal user's username and password, with or without two-factor authentication, with a session token, and a bunch of other options. But I'll let you read the documentation for those specifics. Finally, we get to the fun part, rereading data from Shotgun. On this line, we'll use the find one method to fetch a single project whose name is Hyperspace Madness. The second argument of the method, known as the filter, is a list of conditions that define which project we're looking for. Here we're looking at an example of a basic filter. Each condition in the list has 3 parts: the field we're filtering on, the kind of filter, also sometimes referred to as the relationship, and the value that we're looking for. And then this last bit of code uses the same pattern as above to find the shot to which we'll link our version. Notice that this time around we have 2 conditions in our filter. By default, the filter operator is an AND operator, meaning that both conditions need to be true to find a shot. This can be changed with an argument called filter operator so that conditions are ORed together. Or you can even make complex filters with a mix of AND and OR operators between filters if you would like. Again, all in the docs. Did you notice that in our first condition here, we are searching on a field called code? But for the project, one line above, it was called name. These field codes that we call them, these field codes correspond to grid columns in the Shotgun UI, but may have different names for accessing them in the API. Here are 3 tips to figure out what the field code for the API is for any given grid column in the web UI. First tip, in a grid in Shotgun, right-click on the column header and click Configure Field. In the Configure Field dialog that'll pop up, you'll see the column name for the UI as well as the field code you need to use when referring to that column in the API. The second way to get at this field name to field code relationship is, again, obviously in the UI, in a grid in Shotgun, you'll click on the column management button at the far right of your grid's header. You're going to click on Configure Columns, and in the resulting dialog, you'll see the column name for the UI on the left-hand side, and when you hover your mouse over it, you'll see the field code you need to use in the API if you're to the right. Now this one's really neat because then when you hover, you can really see the field code for multiple UI fields. And finally, third tip, by clicking the user menu and choosing fields, you will need to be an administrator for this. You can access the fields page, which lists all the fields on all entities in the system. You can then find the appropriate field and the API field code right next to it. All right, digression over. Let's keep on going with our script. Now let's add code to create our version. This is our code as it stands, and we'll add a single line to it. You'll notice that the first argument to our create method that we're now using is the entity type of the record we want to create. Version, in our case. The second argument is a dictionary, which includes field codes and their respective values. Here's where we're reusing the project and shot entities we found previously in order to link our version to the right locations in Shotgun. Next, we'll update our version in order to set its status to in review or REV. REV is the short code for that given status. Like the find and create methods, you'll notice a pattern in the arguments, which include an entity type and a dictionary of field values. One extra bit, though, of information that needs to be supplied to the update method is the ID of the entity you're editing. In this case, we're reusing the ID that was given to us as a result of the create call, one line above. Let's take a minute to look at that version variable a little bit more closely. Shotgun records in the Python API are ordinary dictionaries that have two mandatory keys. A type, which determines the entity type of the record, and an ID for that given record. This highlighted dictionary is the simplest form an entity dictionary can have. Because of the standard Python dict nature of the object, you now see how we can use the ID of a record we fetched or created in Shotgun in order to update it later. Now, I said this was the simplest form possible. In reality, our create call returned this second block. When you create a record in Shotgun, you get an object back that includes all the fields you supplied in your creation. So in this case, not only do we have the type and ID, but we also have the name of our version in the code field, as well as entity dictionaries representing the shot and project in the respective entity and project fields. Let's take a second to explore those shot and project hashes that we've got there. These hashes represent values in entity fields of our version. Let's call these linked entities. So on the version, we have linked to the shot and we have linked to the project. They both have a key called name, which makes sense for our project. But in the case of our shot, we would have been expecting the shot name to be in a field called code. A bit of a reminder, here's a UI that says that our shot code field in the UI should be called code in the API. Well, what gives? Well, for linked entities, as these are, this is the name is a third piece of standard information the API returns along with the type and the ID. We've generalized this as being the name of the entity so that you can reliably access the name key, but it represents a human readable name for the record, whichever field really holds that information, like in the background name for a project or code for a shot. What? All right, let's step back and put it even more simply. If the only thing you need from a linked entity is a human readable name for a UI of some sort, this mechanism avoids having to do extra find calls for the linked entities and gives you those names in a standardized manner for free. It doesn't necessarily mean there's a field called name on those records, in this case, the project or the shot. It just provides a human readable form for UI purposes. All right, let's finish this by uploading our media to the version that we created. This last line is, again, very simple. Its format is fairly similar to the update call in that you need to supply the ID of the record you're uploading to, as well as the entity type. The last two arguments are the path to the file you want to upload, as well as the field on the entity you'll be uploading to. And voila, we've got our version record ready for approval with media uploaded to it. It's as simple as that. The eagle-eyed here, or anyone still mildly paying attention, might ask why there's the update call in the script to set the status to review. Couldn't that have happened in the create call? Well, yes, it could. But then I wouldn't have had an excuse to cover the update call, the entity dictionaries, and the name key on linked entities, right? All right. Now that you've got versions for review, here's another scenario for you. You want to create a tool that will prep a daily session. It lets you select multiple versions, creates one playlist per sequence, and adds the appropriate version to that playlist. This is a perfect opportunity to use an AMI. This could be also be implemented as a client-side toolkit app. And if you want to know more about that in, I think, next week's session, Jeff Beelan has a great talk that is related to that. At the end of this scenario, here's what you can expect. Once you click on your AMI, which will be accessible when right-clicking on a version in the Hyperspace Madness project, you can expect a small web server to process your request and create a set of playlists for you that will be visible in Shotgun and playable in Shotgun's review tools, even shareable with clients if you want. This, again, is a very simple implementation that doesn't pretend to cover all possible usage scenarios or error cases. Take it as it is, an excuse for learning about the API. All right, this time around, what are you going to need? In this use case, we'll be showing you how an AMI can interact with a web service that you've written and how that web service can interact in turn with Shotgun. The web service itself is going to be implemented using Flask, which is a lightweight web framework for Python. It's installable like any other Python module and is freely available. All right, on with the AMI setup in the UI. You create your AMI in Shotgun. As an administrator, you'll open the user menu, top right, and click on Action Menu Items. In the Action Menu Items page, you'll add a new Action Menu Item and populate it as follows. Because we're setting up our AMI to work on version entities and in the Hyperspace Madness project, only in this context will the menu item appear. Additionally, we're making sure that the system will require you have version selected before you can invoke the menu item. And finally, the URL is the location that the browser will send information to when the menu is clicked. This URL in the last step can be HTTP, HTTPS, but could also be a custom protocol, for example, shotgun://. This would require that you've configured an application on your local system that understands this custom protocol and can handle it. This is a really, really useful trick, but a bit outside of the scope of this talk. So if you have questions regarding that, hit up support or hit me up if you want to know more about it. At this point, the only thing you've given Shotgun is a location to send the information to. Let's take a look at the information flow at a very high level. Everything starts in Shotgun when you click the AMI. Shotgun then sends a special payload via HTTP, HTTPS, or your custom protocol to the URL that you asked it to. Your code then kicks in, does whatever business logic it's supposed to. And this most probably includes communicating back information to Shotgun using the Shotgun API. Here's an example of the data you can expect to be sent to your code. This is a slightly modified form of Flask request object. I'd like to call to your attention some information which is really useful for custom report building, like the field codes for the columns that were visible on the grid, the human readable name of those columns, sorting and grouping of the columns, that kind of stuff. As well as some other bits of information that I'd like to call out, which are particularly useful for general purpose tools, like the one we're writing. The entity type of the grid you were on, in our case, a version, the IDs of the selected records, the ID of the project you were in, that kind of information. This is going to be really interesting for us later. All right. On with the meaty bits, a bit of code. For context, I wanted to show you the Flask code, but this is by no means a course in Python web frameworks. I just wanted to make it obvious the minimal amount of non-API code that's required for this kind of integration. Here we're just importing our necessary Python modules, which include the Shotgun API. We're setting up our connection and authentication information. Again, not really secure, don't write creds in your code, don't commit them to GitHub. And we're setting up a single route to our server that responds to get and post requests. And finally, we're starting the server. All the real fun stuff happens in the method that's called process versions. And that's what we're going to be concentrating on from here on in. At this point, a lot of stuff should feel pretty familiar in what we're going to be looking, so I'll gloss over a few things, like creating the shotgun connection, for example. I will take a few seconds to call out a few particularly interesting things. Let's start at the top. First, we start by extracting from the incoming AMI payload the entity type that we're working with. In this case, we know it would be a version because we set up our AMI to work on versions, but hard coding it would have been bad practice. Then we extract the project ID from the AMI payload and artificially construct an entity dictionary to represent the project. This is perfectly legitimate. You can manually build entity dictionaries like this and pass them on to Shotgun API methods because that's what they expect, just standard dictionaries. As long as you supply the prerequisite type and ID keys, you're going to be fine. The next step is to extract the IDs of the selected versions from the AMI payload. These are the IDs of the records that were highlighted in the Shotgun grid at the time the AMI was invoked. Because of the nature of information being passed in a post request, standard web technology, standard form data, if you will, these are strings and need to be converted to int. We then build a simple single condition filter, which we'll use in an API find call to get all the versions we want to organize into playlists. Now, here's what I find the most interesting in the AMI scenario, and what should be one of your big takeaways. I've previously glossed over the third argument to a find or a find one call. Now we're going to take a look at it. The third argument is a list of fields whose information you want returned to you in the entity dictionaries. You can specify any field on the entity itself, like in the case of a version, you could ask for code, project, or description, but you can also use linked field syntax. When you're showing a column, a little digression here. When you're showing a column in a grid and you go to the linked field section in the UI, and you drill down through the hierarchy of entities until you get to some deeply linked information, that's the UI equivalent of the linked field syntax. You start off by specifying a field on the entity type you're searching for. In our case, this is the entity field on the version. Then you specify the entity type you're expecting back from that field. You then specify a field on that entity, and so on and so forth, until you get to the information you're looking for. This is an extremely powerful tool. In our case, somewhat reading backwards, we're looking for the code of the sequence that is linked to the shot our version is linked to. Well, what's the point of all this? Well, we want to create a playlist for each sequence our versions belong to. So that means we need to understand which shot they're linked to and which sequences those shots are linked to. Doing all those find calls, and this, if you've optimized this really, really well, it would be at the very least 3 find calls. Doing those find calls would be really expensive. Now, using this linked field syntax, we can get all of our information in a single call. Bit of a parenthesis here. If you've noticed that the field names in the UI of the screenshot don't match the field code in the linked field syntax, remember that field names and field codes can differ. All right, back to our code. The next step here is all about organizing our versions in sequence groups based on the information we retrieved with our linked field syntax. Next is a block of code where we take all the organized playlist information and call it to Shotgun via the create method. This create method you already know about. What's interesting to note here is that the versions field on the playlist entity is a multi-entity field. That means the field can hold many versions. It should be noted that it's as simple as supplying a list of entities in the data dictionary, and the multi-entity field will be populated with more than one item. It's really pretty easy. We tried to stick with the Python API to really standard Python mechanisms and parallels. And finally, last line, we just return a bit of information for Flask server to return some content. This is a bit of boilerplate. Once all this back and forth between Shotgun or AMI code and back to Shotgun has happened, you're left with a list of playlists that your users can view and use in dailies. Even send to a client if they wish. So now that we've covered all this, what's left? Well, there are tons of stuff in the Python API that we haven't even looked at. Deleting, reviving stuff, batching calls together, which is good for update calls, which is good for create calls. You cannot, however, batch find calls. You can summarize information, have the database summarize information for you instead of you doing the computations on the Python side and fetching a lot of data to do those computations. You can follow stuff like you would in the UI. You have schema methods to understand how your information is linked, what fields you have on various entity types. There are obviously a bunch of REST API specifics, like REST API authentication, the Shotgun event daemon that we skipped over, and tons more stuff that you can look at. But that's the time that we've got for today. So I am going to open it up for QA and just drop this slide here for a couple of seconds so you can grab the QR code if you want.
I'll jump on. We don't have any questions in our little Q&A box. We are definitely open to answering them if people are coming up with any in these last moments. We've got some time for sure. And if not, then I think we can actually end a few minutes early, although we can still go back to questions. I will say quickly that this was the first of 3 of these webinars that we're going to do to cover the 3 courses that we did during Dev Day. They're going to be consecutive, so it'll be next Thursday and the following Thursday at the same time. The next 2 will be a little more advanced. The next one is, although not to say Patrick's definitely went deep in, so a little more advanced than our intro. The next one is more focused on Toolkit, and then the following one will be on more advanced topics, writing apps, Forge integration, which is really cool, and our distributed pipeline configurations for multi-location workflows and things like that. So I hope you will join us for those. If you want to get in touch with us, always support@shotgunsoftware.com will get to us. I think that's it. I think we're good. Thanks very much for joining us. All right.
Thanks, everyone.
Oh, we have a question. Hang on. Oh, just a thank you. You're very welcome. That's it. We'll hopefully see you guys at the next one next Thursday. All right. Bye.
See you next week. Bye.